Okay, this video is going to cover the homework from Tuesday, which is Chapter 3, Lesson 5, Day 2, Dividing Decimals. So looking at all of these, we are still going to try to take an estimate to figure out what would be reasonable, and it's also a good flex of your mathematical reasoning skills. So I know 48 hundredths is really close to 60 hundredths or 6 tenths, and 60 hundredths divided by 6 hundredths would equal 10. And so because this first number, our divisor our dividend is a little bit bigger than what our dividend of our original problem is, I know that our answer here is going to be a little bit bigger than what we need to be, so I should look for an answer that is less. So looking at these, I'm going to start out and use the fraction strategy because I know 48 and 6 are pretty related. So 48 hundredths divided by 6 hundredths, and I'm going to multiply by the reciprocal, 48 hundredths times 100 over 6. So these will both simplify, and I'm just going to write this as 48 sixths before I simplify too much. Since these are both 1, I might as well, and because I recognize that 48 and 6 are related, so in my head I'm thinking this is the same as 48 divided by 6, which is 8. So my answer is 8, and that does check out with my reasonability. So again, here I know that for question number 2, 63 hundredths divided by 9 tenths is going to be pretty related because I recognize 63 and 9 are factors or they're mathematically related when it comes to multiplication. So if this was 9 tenths divided by 9 tenths, it would be 1 because there would only be 1 9/10 in there. And so I know my answer is going to be just a little bit less than 1. So again, on this one, you know what? We might as well just do some more fractions. Why not? So 63 hundredths, sorry if you can hear the dog walking in the background, divided by 9 tenths. Well, 9 tenths is the same as 90 hundredths. We know that. Let's just multiply by the reciprocal and see what we get here. 63 100ths, times 10 ninths. This is going to simplify to 1. That'll be 10. So now we have 63 90ths. You know what? Let's not do that. That seems like a mess. Let's actually simplify these. Divided by 9 is 1, and this divided by 9 is 7. So I'm left with 7 tenths times 1 over 1, which is equal to 7 tenths as a fraction, or 7 tenths as a decimal. Convenient how that worked out. Definitely seems worthwhile to simplify before you multiply, because then you're left with some pretty easy stuff right there. Looking at question number 3, this one seems much less familiar. Much less familiar. And so we know that with division and there's proportionality, and if we multiply our dividend by a number like 10, and we multiply our divisor by a dividend like 10, or by a number like 10, then our answer is going to stay the same. Both numbers in this equation are proportional, so we can manipulate them that way to make it easier to divide. Because I can handle doing 9 and 28 hundredths divided by 2 relatively easy. It's that 2 tenths that kind of screws it up in there. Since I'm doing this, I am going to look at branching for this one because we haven't done that in a while. And I know that 9 is like an 8-1, and then I'm left with 12, or 1 and 28 hundredths. 8 divided by 2 is 4. Now I'm going to look here. I can't do the wholes, but if I focus on the tenths, I know that I could pull out 12 of those tenths, or 1 and 2 tenths, and 12 tenths divided by 2 is going to be 6 tenths, and 6 tenths is written like that. And I made my branches here just a wee bit too small, so now I'm left with 8 hundredths. And keep in mind, as I'm solving these two, especially right here, I'm thinking of them using the words. Like this is 12 tenths divided by 2 is 6 tenths. And now I have 8 hundredths divided by 2 is going to equal 4 hundredths. And so just relying on that language is going to help keep me very accurate. So that way I don't mistakenly put the place value in the wrong place. So now, if I combine all these together, 4 plus 6/10 plus 4/100 is going to be 4 and 64/100. Oh man, I didn't even do a reasonability check. That stinks. Well, let's see. If we round this up, how many 2/10 are in one whole? Well, there's 5 of them. So I guess this does check out. I just didn't do that ahead of time. So, moving on to question number 4. Ooh, this one looks pretty ugly. It doesn't seem like it's going to be very friendly for branching. Doesn't seem like it's going to be very friendly for much of anything else. Sorry, mute my computer. So I'm going to look at this one. And first, let's figure out what would be reasonable. And I know if this was 48/100 divided by 6/100, that would be 8. I want to say it seems like 8 would be reasonable because 2 groups of 6/100 would be 12/100, and then there'd be 4 more of them. Okay, so 8 seems pretty reasonable. So this one, though, I am going to use that same idea of proportionality where if I multiply both of these by 100, because I want to move this decimal point 2 places over. So if I multiply them by 100, I get 44 1/10 divided by 6. And I'm going to set this up and do it long division style because it's just not quite as neat. I mean, we might be able to get away with it using branching, but let's look at this one just for the fun of it. So I know 6 goes into 4 0 times. 6 goes into 44 7 times, and that's 42. I can subtract, and I'm left with 2. Now I am going to bring down this 1/10 from before. And so now, again, I'm thinking like this language over here on this side with like our place value language. And that's going to help me stay kind of grounded in what these numbers mean. So we now have 21/10. And I want to know how many times will 6 go into 21. And I know that it is 3 times. But these are tenths, so that's 3/10. And 6 times 3 is 18. Now when I subtract, I'm left with 3/10. Well, fortunately for me, I know 3/10 is equal to 30/100. So I'm going to think of these tenths in terms of hundredths because that gives me more pieces to work with. So 6, now I'm thinking about these like 30/100. 6 goes into 35 times, and those are hundredths. So there we go. My answer is 7 and 35/100. Now let's check that answer key, hopefully. Whew, hot dog. According to the answer key, we got it right, but question 5 says to pick a question above and solve using another strategy. You know, I think, I don't know, 3 and 4 are the ones that seem like I would be most shaky with. So I'm going to probably solve one of those using another strategy just to see if I've done anything wild here. So let's, you know what, for the sake of it, I'm going to do both of them for you just to see. So let's do long division for number 3. We're going to keep using that idea of we multiplied both of them by 10, so that's not going to affect our quotient. So I know 2 goes into 9 4 times, and that's 8. Leaves me with 1 whole. I'll bring down those 2/10. 2 goes into 12/10 6 times, but those are tenths, so I'm going to make sure they stay there. And that would be 12/10. So now I'm left with 0, and I'm going to bring down those 8/100. So 2 goes into those 8/100 4 times. Those are 4/100. And that leaves me with nothing. So we did get our same answer there. That makes me feel pretty good about that. Let's see if we can tackle question number 4 using branching. So we are going to use this proportional one again, where we have 44 1/10 divided by 6. So I know that we can pull out 42. 42 divided by 6 is 7. That leaves me with 2 1/10. And so I know 2 1/10, or 21/10, is going to be 18/10. I'm going to abbreviate it like that. And I'll get 3/10. And 21/10 minus 18/10 is going to leave me with 3. 3/10? 3/10. Well, 3/10 is also equal to 30 hundredths. And 6 goes into 30, I can divide that. 5 10, ooh, okay, 6 there, oops. And that would leave me with 5 hundredths. So I've got my lovely place value language here, so I know when I rewrite these, it's going to be nice that this is a 3 in the tens place, a 5 in the hundredths place, and when I put all of this together, I get 7 and 35 hundredths, which checks out.